So, as John already said, the title of my talk is Data Visualization and Statistical Modeling in Shiny. And just to give you a brief overview of my talk first, I'm gonna first introduce Shiny. Then I'm gonna have a brief overview of how someone can share a Shiny application. Afterwards, I'll show you a couple of attempts, personal attempts at creating Shiny applications. And then we're going to take it one step further and talk about some really interesting things that Shiny has to offer without actually needing to know almost everything than the previous stuff. So you could use the stuff at the end, HTML widgets and all those stuff, kind of independently. But before I do that, I actually realized that this is the main topic today is 20 years of CRAN. And not just that, but on the same side, I understood that exactly 20 years to the day, it was the first version of R was into CRAN. So whoever thought of that from the committee, well done. That was really nice. My first idea was, while I was in Greece for holidays. I was trying to find pictures of myself from 1997. And it was a bit funny because the majority of the family photo albums stopped at 1984. Which is when I was born also. So that was a bit interesting. I had an interesting discussion with my mother. And after that I said, okay, let's try and make people feel a bit old. Because unfortunately, unlike John, some of us are a bit old. And I have a bit of trivia, 1997 trivia. So I broke down into 3 parts, feel free to. And that is actually, okay, that is the previous version. We'll have all the trivia at this page. So I have the top 3 box office hits in the world, top 3 rated TV shows in the US, and top 3 singles music chart in the UK. Anything for top 3 movies, 1997? Sorry? Titanic. Titanic. Is there anything else? So we have number 3, Jurassic Park. Number 2, Men in Black. Number 1 is Titanic. So for top 3 rated TV shows, it's Friends, ER, and Seinfeld. So Seinfeld existed at that time. And that is actually the 3rd part is where I actually started getting really, really old, because I kind of remember all those songs. Any ideas about top singles in the UK? Sorry? It wasn't top 3. It was close, but it wasn't. It's all high quality songs. They start with Barbie Girl by Aqua. I mean, they do get a bit better, so you do have Candle in the Wind afterwards. And that's a really nice song, actually. I'll be missing you. Hopefully a lot of people remember that. So that made me feel a bit old, that all these things happened in 1997. But let's start with the talk. So what is Shiny? So Shiny is nothing else but an R package, and it does a really specific job. It provides a web framework for building web applications. The really nice thing here is that if you know R, you can actually turn all the analysis that you have, all the things that you're doing in RStudio or in any other, or from the terminal, if you use it like I do, you can actually turn all your analysis into applications that have 2 really nice things. First of all, they're interactive, and secondly, anyone can use it. So we'll see later on how you can share those applications. The really nice thing for the R users who create the Shiny apps is that there is no need to learn anything more. So there is no need to learn HTML, CSS, or JavaScript. So just with your knowledge of R, you could use the same syntax and create a Shiny app. So the best way to start with Shiny, and I have it in quotes because this is, well, what I consider the best way, and I'm a bit biased because this is the way that I started with Shiny. I've broken it down into 3 steps, even though I don't think it's even 3 steps, but let's say it is. So first of all, you just install and load the package as any other package in R, with install packages and library. Secondly, what I would advise you to do is go to the official Shiny and RStudio webpage of the tutorial, and you're going to see there's a 7-lesson tutorial, and I will tell you to finish all its exercises. My personal experience that it would take you somewhere about 3 hours. And this starts essentially from you knowing nothing about Shiny and knowing a bit of R, though, but knowing nothing a bit of Shiny. And I see Ben right now, he's not sure if he wants to enter. We'll find out. And finish all its exercises. By the way, the footnote that you can't see at the end is I'm telling you that this should take you close to 3 hours. Okay. So Shiny, on the other hand, has become increasingly popular. and you can find lots of how to start tutorials online. So my personal favorite, but again, a bit biased because I really like this guy. He's a really nice, shiny web developer. So Di Natale, and by the way, all the slides will be available later on, and you can go on top of all those links, and you'll see where you're going to. Di Natale's tutorial is one of my favorites. He has a really nice way of explaining things. So that is what I feel the best way to start with Shiny is. So let's talk a bit about the structure of a Shiny application. And the Shiny application consists of 2 files, and I should have put actually a small asterisk there because I'll tell you something at the end of this slide. That's not entirely true. But let's say it is. A Shiny application consists of 2 files. The first one is a user interface definition script that is titled UI.tar. And this actually is what controls the appearance of your application. So you could think of this R file as the design of the car. So how does the car look from the outside? What color it is? You know, what kind of wheels it has. And the server script that is titled server.tar, and this is essentially where all the magic happens. This is the script that controls how the data are processed, so you could think of it as the engine of the car. So this is where all of the functions, all the modeling that is actually happening on the background is. Okay? So you can actually create a Shiny app by making a new directory and saving within that directory the UI.tar and server.tar files. And it's actually, I'm not trying to be, you know, push it with the names. It's actually, it has to be those specific names, UI.tar and server.tar. Okay? So after you do that, after you create a directory with those files, the only thing that you need to do to run your Shiny app. Yeah. Okay. So you could also, it also allows for mathematical notation essentially to explain all the models that someone can use. Besides that, what you could also do is you could actually show your data specifically as a table and focus on whatever thing you're interested on. So you could sort it, let's say, by arson. And you see in this case that Austin, the community Austin, is by far, for 3 different years, has the highest values. So let's try battery. The same thing is happening for battery actually throughout the years, and probably there is a reason behind it. I'm guessing it's the population, but let's check about that. And that is the reason. So it's essentially Austin is by far the biggest community there. And these are, by the way, the reason why these are not integers, because these are estimations of population for each year. Okay. The really nice thing here, though, is that it allows you, to focus on specific columns, show and hide things, or move things around to your liking. Another thing that I want to show you is the data visualization that Shiny allows you to do, and it allows you to save a lot of time. So I stopped doing actually those things from the terminal and just change variables. I put all those things into Shiny with windows like this. So let's say at the x-axis we put the median family income. You see that it starts changing, and let's put at the y-axis the battery, number of batteries, and let's focus at whatever, the last 6 years. So right now we could see all the different stuff that are happening here. Somebody could actually be interested at what is happening right here, and the moment you go at this data points, you see them that they pop up right here. So it's essentially the same community, Lincoln Park, that consistently has really high median family income. You could obviously double click at this side and focus a bit more specific on the things you want to have a look at. You could actually go back here. You could actually do exactly the opposite. So let's say that I'm a bit interested again at Austin, and I want to see where actually is 2004, which it's up here. So if this was bigger, we could have seen it immediately change. But essentially, Austin has all these high values of battery right here. And whatever you change, salt, you can see where the new stuff are going. So you could do a lot of data visualization and tree maps and stuff like that. I think by far, to me, the most interesting thing that you could do in this situation is you can allow the user to decide on what sort of model they want to use. So you don't tell the user, this is the model that you're going to use, just check the results from this model. The really nice thing is that you can actually run, in this case, I don't want to go too deep, but I'm going to run an MCMC chain. And the only thing that I'm going to change, just to make it a bit faster, I'm going to make a number of samples 500, length of burn in 100. let's say that I want to focus again on the last 6 years. I want to choose the response, and the available options are right here. I'm going to put arson here, and the variables you want to be included in the model. I'm a bit lazy, so I'm just going to copy-paste stuff. So we'll put the median house value. And the family is below poverty percent. We're just going to throw the comma out. And the way that we write those things is, well, the way that I did it is like an LM function, so you just need a plus sign in between. The thing that you could do afterwards is just run the model. And, well, it was really fast right now because we put a small number of samples. But essentially, you could see the results immediately. You could see the regression model, the summary statistics. You could actually use, and this is what I feel really nice, you could actually use a lot of additional stuff like, interpretation of the coefficient, statistically significant effects. And you can do this in kind of layman's terms so anyone can use and take advantage of what the summary statistics above are telling us. It also allows to plot everything and to actually use maps here and actually show the fitted values throughout the year that we chose, the rates for each year. So you could actually have a bit of visualization of what's happening. So here, from what I see regarding to rates, we see at the center and at the south, we have a bit of higher rates for arson. So that's the first thing that I want to show you. Hopefully, this version has what I need. Yes, it has. So the question that we faced at that time when I started creating this app is, wait a minute, that is an okay app, but it's way specific. So, okay, it allows me to use any model that I want from some available options, but it doesn't allow me to change the data set. So this only works for your data set. And the question that we had is, can we create a more generic application where anyone can upload their own data sets and start applying different models for spatial temporal data? And the answer to this is obviously yes, we can. And the idea for this app, it doesn't even look like an app at the start, so it's essentially an empty application at the start, and it waits for you to upload the data set, and then it starts becoming an actual application. So I want to show you a bit of how this works. Takes a bit. Okay, so this actually, right now, it has a lot of different tabs, but everything is empty because nobody has actually uploaded a data set yet. And the idea is that you could choose any CSV file from your computer, and I should have done that before to find desktop here, yep. And files for generic apps, so the only thing that you need to do is upload a CSV file. The upload is complete, you get some structure, summary statistics and tables, some really introductory stuff here. You could also do different visualizations. So usually, by the way, on the laptop, this looks nicer in the sense of the pixel settings. So let's put up the Y median family income, and let's have the size of circles, whatever. Let's have population. Let's go a bit here. Again, here, you could change different years. You could go on top of its thing and see what exactly are its values. The really nice thing also is that it allows you to actually save all the plots that you make. So instead of going into R, and even if you don't know R, you don't need to know R to create these easy plots and save them and put them at your paper or at your report. And this is actually a package that probably most of you have heard. So this is called Plotly. I'm going to show you a bit later on. It's a really nice package. It allows for interactive graphics in almost the syntax that you already know by R. So you just need to load the package and just change a small thing. So it's really simple. And obviously here, again, for modeling, if we go at model, here I need a bit more in order to run these models. So here I actually need to download the shape files. I'm not going to go crazy right now and rerun the same model, but once you upload all the save files in the application, then you can start using the model as before. So it essentially allows you to do whatever you could do before. So this is a more generic application compared to the next one. It can be used for all sorts of different data sets. And well, this was supposed to be a good time for me to tell you what great application it was and what a great idea I had, but I actually kind of stole the idea from a thing that I will show you right now, which is, well, 10 times better. And I would definitely tell you to use this. So last but not least, I want to show you 4 different things that I feel are really, really nice, independently of you wanting to go down the shiny path and, you know, refresh a bit your eye and start playing with this. So first of all, HTML widgets. And I'm saying there, I'm giving a really short summary that they work just like art plots, except they produce interactive web visualizations. We already saw a couple of those. I just want to show you a bit how easy it is to use HTML widgets, and just to show you where to go for those things. So you go up, see the showcase, and do you go out to see the showcase? Let me find out. You should go out to see the showcase. I was right. So you go out to see the showcase, and usually here, by the way, you have all the different HTML widgets and not leaflets. So I'm trying to find out. Oh, maybe it's here. Maybe the chain. No. So, and this is the GitHub version. So that's a bit of. I did not expect that. Obviously, something would have happened today at the talk that I didn't expect. So, but I'm pretty sure that when you load this later on, I will check it again. They actually have close to, I want to say, 12 to 15 different HTML widgets. And right on the right-hand side, it always gives you a bit of an R code of how to use it. And all joking aside, all the R code you need is 3 to, I want to say, 6 lines. It's nothing that, oh my God, I can understand what's happening. So it's really simple stuff, and you can take it to advantage widgets that are related to maps, interactive maps, interactive tables that I showed you before, that you could change columns and stuff like that. It has a lot of info here. I will check again the link later on just to make sure that you have exactly what I have in mind. So that's HTML widgets. Second thing is Show Me Shiny. And it's a website that presents lots of Shiny applications along with their R code. So this is actually, I feel it's a really nice website for beginners in Shiny. And especially when you know what you want, and I mean, you've Googled it, and you can't seem to find the answer somewhere, it's almost certain that the answer is at Show Me Shiny. So they have a lot of apps there with their R code. It would be funny if it throws me again at another link. Hopefully it's going to be the correct one. So, yes, so you could go at each of those apps by varied regression, and it provides information about each app, and most of the time they also have the code available. In this case, it's from, I'm guessing, right here. So, well, in this case, yes, included in app interface. So a lot of times, as you see here, the code is available on the right-hand side of the app. So you could immediately actually see what's happening when you change something. What is the reaction that is happening on the code? So this is also another really nice way to start getting introduced with Shiny. But this was a website that I played a lot with when I couldn't find the things that I want to do. So Show Me Shiny is really important. I think by far the thing that I stole a lot of ideas from to do the generic app. It's called Radiant, and well, I would advise everyone that someone is giving you data to start putting the data immediately on Radiant. It has a lot of nice things that you could do. So what is Radiant? I should have started there. So Radiant is a browser-based interface for business analytics in R, and you can actually use it online, which is what we're going to do right now, or actually clone the repository from GitHub and create your own version of Radiant. So the code is freely available. You can change whatever you want. You can add things to it and make it your own version, and you publish it as your own Shiny app at the end. So all these stuff are allowed. So Radiant is made by, I want to say, a Dutch person. I'm pretty sure that Vincent, I'm not going to try the surname. Vincent is Dutch. She has done a lot of really nice things. The website is ridiculously informed. It has a lot of info. So you could spend hours looking at the website and the page in general. What I would advise you to do is to actually, for a first start, to actually go at where it says try Radiant online. So there is no need for you to install anything at all. So when you try Radiant online, it will throw you immediately at the Shiny app. And by the way, well, Vincent has already pre-installed as a dataset the famous, famous for us, statisticians Diamonds dataset. But what you can actually do here, again, is you can load your data. You can say, hey, I want to load my CSV, and it's what I had before. So you will immediately see your data set there. The really nice thing here is that it allows you to do so many things. And by the way, this time right now, I'm going to spend 3 to 5 minutes. I think I'll show you close to 10% of what you could do. It's a lot of stuff. So you can actually, first of all, view the data and focus on each variable you want, or put specific, I think it needs an enter. No? Well, you could change things like that. You could visualize your data immediately. So you could say, maybe I want a distribution of battery to see what is happening, and let's play a bit with the bins to see if there is any sort of change. Again, what Vincent has allowed is you can immediately download any plot and use it for your report without knowing any ggplot or any R at all. So this is just you having data and putting it online and working on find what sort of type should be put here and there. Another really nice thing that I've used a couple of times, it also allows you to combine different CSV files and different data sets. And it has a lot of different options right now because I've only uploaded one data set. It has by default two, the one that I uploaded and the preloaded Diamonds version. But you could even upload more stuff, and you could actually decide to add variables at your data set, specific variables, or have all the different combined combinations. So that's a thing that I've used a lot here. The reason why I told you I would spend 5 minutes here and probably maybe less than 10% is because all this time I've just been talking about the first tab over here, which is the data tab. So you probably now see that it has a lot of different tabs, and each one has a lot of different things that it does. It's a really nice app. I would tell you definitely have a look at that. I will put definitely the slides later on, so you could go and click on the link immediately. So let's go back here. So Radiant, I feel Radiant is by far for me the best generic signing app that I've seen online. Now I'm going kind of the opposite way. This is still one of the best apps that I've seen online, but it's the opposite way in the sense of generic. It's really specific. It's for people who use MCMC and they want to do a lot of MCMC diagnostics. So ScienceTime, you probably figured out, well, it's a combination. Wait for it, signing and stan. So this is a graphical user interface essentially for interactive MCMC diagnostics. A couple of things that I want to talk about before I show you how this looks, because it looks really nice. I feel it's a lot of work that the SAM people have put into this app. The two really important functions for this app is the launch signing stan and the ask signing stan. A lot of you, kind of me included, you're not really well versed maybe in stan. What this app allows you to do is you can actually use any MCMC object into this application. You just have first to make it what stan users call an SSO object, which means a signing stan object. The way that you make it a signing stan object is you use the second function, so as signing stan MCMC sample. So you have your MCMC sample from another package, and then you make it a signing stan object. It has some specific things that it wants you to do, but they're simple stuff. The second thing is once you create the object, this is the argument that you have to put into launch signing stan. So when you have launch signing stan, it needs, well, it has a lot of arguments, but the main one is the first one, which is the actual MCMC posterior sample that you have. So that's all you need to do to actually run the app. So right now, hopefully I'll go a bit at RStudio. So the only thing that I've done, and you can see right now, is that I've just loaded the library, ScienceTime, and as I said before, you could actually, when you have your own SSO object, you just have to use launch ScienceTime with that name. In this case, I'm going to use the launch ScienceTime demo, and this will pop up the browser of how your dataset will kind of look like, but this has also a preloaded dataset. It's called Data Schools. Again, it looks a bit empty, but it's all the different tabs that it has. So it has a diagnose tab. Something is happening here. Let's try this. Okay. Let's try this again. So you put diagnose here. So you immediately, well, in this case, they had actually run more than one MCMC chain. You could actually put that I just want to have a look at the first chain, so you immediately see a diagnostics of the chain. You could also check which is the parameter that is maybe informative to what you're doing. I'm guessing this is the precision, but I don't know. So, well, yeah, the range space looks okay for it to be a precision. So you get a lot of diagnostics there. You could also do a lot of estimations, a lot of plots for you for the credible intervals of your posterior sample. And again, all these things are downloadable, so you don't need to do any plotting at all. You just put your SSO object there. A really nice thing that it has also, it generates a latest table for you with all the data that you've inputted. So again, you know, if you are really, really lazy and you don't want to do any MCMC diagnostics at all, this is a really, really nice app to use. And again, this thing, I don't want to spend a lot of time into this app because it has a lot of different things. You could go crazy with the plots that it has, and you could go really into deep with any specific parameter of your MCMC sample. So that is the fourth thing that I wanted you to have a look at. Unfortunately, all four things are way better than my work. That's about it. I think that this is going to be the last. Oh no, I have some general comments at the end. So these are the four really nice things that I would definitely tell you to have a look at, depending on you liking the shiny part. I think especially Radiant and ScienceTime are really good. So some general comments. And I think you'll see most of these things later on with Colin and Mike. So I feel that Shiny provides a really quick way of presenting your data interactively. I think it's also really good for engaging with people that, you know, maybe they're not statisticians, they're not researchers at all. So with the general public, I think these are things that you could put online and let people decide on what they want to look at and work on. By far for me, well, I'm Greek, so I don't have a lot of support for, you know, large groups of people. I don't believe they're organized and stuff like that. Apparently, the Shiny people are ridiculously organized. I mean, it's a bit funny how fast they are in replying to questions that you might have. So even though Shiny is still in development, it has an excellent community support. I've put two different links there. I mean, I don't want to take it on me, but I would find it strange if you haven't found an answer to your question and you post something at any of these two things that you won't have an answer within a day. So people usually, and especially the, I don't want to pronounce his name, Siem, something like that, the person who's behind Shiny, he's ridiculously good at answering those questions in a nice and simple way. So definitely use those two things. The thing that I didn't tell you earlier, and especially for the Shiny users out there, you probably already noticed, but still, so things become a bit tricky. I should have put probably and/or, rather expensive, not just or, when it comes to the privacy and security of the data, and also the amount of memory needed for your application. So as a small example, so the Radiant app that I showed you before, so I used it online. If I put the 6 million rows for the Chicago dataset, you would have probably found out that the applications, well, either they take a long time, which when I say a long time, I want to say 10 seconds, or they actually break down sometimes. Now the same version of Radiant from R always works. So if you download Radiant as a package, you won't have an issue. But sometimes online, when you put so many observations, it may have an issue. So that's about it. Hopefully I didn't go crazy with time. We'll find out. And thanks a lot for listening.
So it was really fascinating, some of the applications you showed us, especially Radiant looked very good. And you showed the possibility of uploading a CSV file of your own data into that. I mean, do these things support connections to other data sources, or does it always have to be you go there and you upload some data of your own?
So, like what other data source? What do you mean?
I suppose I'm running this, for a business intelligence thing. I have a database with customer records of some kind in it, and I want to connect.
Oh, that's a good question.
As a visualization for that.
I'm not sure about that. That's a good question. I'll have to check that. That is a good question. The only thing that I know that Radiant definitely allows, it allows for, I want to say, close to 20 different options for the extension of your file that you might have. I don't know if it has any sort of SQL thing there. I have to check that. It has a sort of database related stuff. Nothing comes up to mind right now for something like that, but that doesn't mean that it doesn't exist. And definitely, in a lot of things that exist right now in Shiny, 3 months ago they did, so they still put a lot of stuff right now online. So yeah.
So I imagine if you've got the general public working with Shiny, they'll have different data sets coded in different ways. So does Shiny give you the option of, say, having a standardized formatted Excel spreadsheet, for example?
Yes. So a thing I should have shown that. A thing that I should have shown you is that all the stuff that you showed before into data, that you just played with the data columns, all those things can actually be exported into Excel, and you could actually do a lot of not just work on summary statistics, but do actual modeling, and then get all the results immediately as an Excel file, so people could immediately download them and use them for whatever they want to do. But I think in general, the thing, well, I don't know if it's nice to say, but hopefully all of us are a bit, lazy in a sense. I think a lot of these Shiny apps help us to be even a bit more lazy in the sense of they do a lot of work for us that we actually, a lot of times we spend a lot of time, even for me at least, changing factors, finding what is an integer and shouldn't be an integer. Those things pop up immediately into those apps, and I think that they're really helpful in general.
I think it was in Radiant, there was an option for repetitive experiments.
Yes.
What kind of options are there? Exploring them experiments? Or?
I don't know. I don't know if Vincent, again, there, so I'm sure that for each tab he has there, it allows you to include data sets of your own. I don't know if there, the design of experiments, it's only you only have a couple of options to play with. But he also has regression, also there that you could do a regression and a lot of other things.
No questions from Twitter.
Oh yeah, we have a Twitter feed also. We shouldn't make them feel sad.
If I don't make calls, you know what I mean?
Yeah, exactly.
Okay, well, everyone can thank you again.
Thanks a lot.